But the pattern that was there that was argued so strongly, like, oh, this has got to be evidence for evolution. What other explanation could there be? Well, now they have to explain it a different way.
G'day, it's Ken Colson here from Creation Unfolding, and again we've got Dr. Matt McLain from the Masters University with us. So Dr. McLain is the Dean of Science out there at the Masters University. He's also teaching classes in geology, teaching classes in paleontology. So Dr. McLain, welcome back to the channel today.
Hey, thanks. Glad to be here.
Yeah, so what are we going to be looking at today?
We're going to talk about fossil footprints again. And for some of your viewers, this may feel kind of familiar, almost a little bit of deja vu, because I feel like, didn't we talk about footprints with tetrapods and Tiktaalik and all that kind of stuff before? We did. This is a little bit different, but it actually ends up tying into that question as well.
Yes, so I did read the paper, and they talked about Tiktaalik, and they talked about time frames there. Are they using the new footprints, the ones around Tiktaalik, to come up with that time frame?
Yeah, actually, at least one of the authors on this new paper was involved in that study on the Zekelme tracks with the Tiktaalik ones. So yeah.
Yeah, that's kind of interesting. That's kind of his field, and he's finding these footprints that are sort of out of order, so to speak.
Yeah, it's shaking things up, and there's a certain sense in which I think this paper is even more exciting and more disruptive than the previous one. So I think it's very, very exciting.
Okay, so tell us about it. What's the thesis? Why is this important from a creationist perspective?
Yeah, so before we were talking about Tiktaalik, we brought him up a few times, right? Tiktaalik is the fishapod. It's the thing that's supposed to be transitional between a fish and a tetrapod, a four-legged animal, right? So that's supposed to be about the ancestry of all four-legged animals. And we talked about in that video how the actual fossil record, body fossil record, fits really nicely, right? You get fish, then you get Tiktaalik, and then you get your first tetrapods. But the footprint record doesn't follow that. So the footprint record, they discovered footprints that are older than the oldest body fossils of tetrapods. They're even older than Tiktaalik, and they're down there where you'd only be finding fish. And so that was a very big surprise, and that has raised a lot of questions about the order of things, and especially because the belief on the evolutionary side of stuff is that the order here really does reflect the order in which these creatures evolved, right? So it's not like these are like, death nails, like, evolution can't recover. There's no other alternative. Yeah, they can figure out a way around this. But the pattern that was there that was argued so strongly, like, oh, this has got to be evidence for evolution. What other explanation could there be? Well, now they have to explain it a different way, just like we do. That's kind of cool. And so now we've got a similar situation, but this one we're going to go a tiny bit higher in the record. So we were in the Devonian looking at that stuff. We're going to jump up one system or period, and that's the Carboniferous. Okay, so the Carboniferous, that is the one that's famous for coal, right, in the United States and in England. There's tons and tons of coal in there, and that is where you get your first, what you might look at and call an amphibian, as well as your first amniotes. So an amniote is the group that contains reptiles, birds, and mammals. So these are animals that can lay their eggs not in water, right? They can actually lay them on land. And you might think, well, mammals don't lay eggs. Some do, right? Platypus and the echidna, probably a lot of fossil ones. And even though most mammals give birth to live young, the actual membranes and fluids that are inside, surrounding the developing embryo are the same kinds they're homologous with the things you find in reptiles and birds, right? So that whole group, those animals have skin that is water resistant, they're very good at water retention as well. So we don't have to constantly live in pools, right? Like a frog or a salamander. And so your first amniotes in the fossil record are in the kind of middle Carboniferous. That's when you find your first reptile-looking things, right? And the first footprints of those are a little bit lower in the Carboniferous. So everyone was like, oh, we knew amniotes evolved a little bit earlier, but everyone kind of thought the way it worked, right, is your first four-legged animals evolved in the Devonian. We already talked about that, right? Your first tetrapods. And then you go from the Devonian into the Carboniferous, and it's during the Carboniferous there is this belief that you had this sudden burst of diversification of tons of types of amphibians, and then your amniotes, your reptile-like animals, finally appear after that. And that was kind of the general flow of things, right? So I can even show you really quickly.
Yes.
I'll try and share my screen with you.
Yeah, that'd be great.
This is a phylogeny from Michael Benton's vertebrate paleontology textbook. This is one I use in class when I'm teaching vertebrate paleontology. And this is showing you the appearance of amniotes. So that's our reptile, bird, and mammal group, right? And the amphibians are kind of over here. And then Ichthyostega, right, our first tetrapods would be down here. So you can see this is kind of the traditional way of thinking about it. In the Devonian,
Audience, that on the left there, you can see the different periods of Earth history.
yes.
There's the geologic column.
Yeah. So down here in the Devonian, right, you get your first tetrapods, your first four-legged animals are showing up. And then the idea is that here's the Carboniferous, the one we're talking about. This lower part of the Carboniferous is when all these different groups of amphibians are appearing, right? All these different lineages. And then out of one of those, up near the top of the Carboniferous, you get your first amniotes, your first reptile-like creatures, right, popping up here. And that's, like I said, going to turn into the reptiles and birds and mammals. That's the idea. Whereas all these other lineages of interesting things, most of them go extinct, but some do continue eventually into our frogs and salamanders. And that's that idea.
So I think the point to sort of focus on here would be that essentially it seems like from that phylogeny in the Carboniferous, it's all basically amphibians.
Right.
Right.
That's the idea. Until you get near the top, and then you start getting some interesting reptiles. Now, they haven't actually, Benton in this diagram, he hasn't broken apart all the different amniote groups. There's actually several of them in the Carboniferous, but he's just condensed it down to one line. But he's exploded kind of the amphibian part of it and showing you that. But you can see most of the Carboniferous is things that we might think of as amphibians.
Right.
We kind of call them that. And you can see there's a nice progression here, right? You'd have fish down here in the Devonian, your first four-legged animals, then you've got your amphibians, then you get your reptiles. That's kind of like that nice order, how the fossil record's typically spoken of, right? When you think about an evolutionary story, okay? So what's really interesting about this new paper is that they found new footprints that really shake up this whole narrative. Okay, so this is the paper, Earliest Amniote Tracks Recalibrate the Timeline of Tetrapod Evolution. And this was published in Nature just recently. And these tracks were found in Australia. Okay,
Hey,
so I'll show you what the tracks. What's that?
My neck of the woods.
That's right, yeah. Now, not exactly your neck of the woods,
No,
closer than me.
You want to know, I'm in Queensland, by the way.
So, what I'll show you here, these are some of the footprints that they found. So you can see clear digit impressions on these, right?
Yep.
Some of these clearly have 5 digits.
Yep.
And this one in particular is really cool because you can actually see claw marks. Okay, now that's important because the amphibians that we find in the fossil record, they don't have claws. And most modern amphibians don't have true claws. That's a very amniote trait, right? Reptiles, birds, and mammals, they've got the claws, the nails, those kinds of things.
Right.
And so that's very, very interesting to see that here. And they found similar tracks in Poland. They're a little bit later, but where you can see actual claw marks and 5 digits, all these classic amniote characteristics, right? So where are these tracks coming from? Well, we said they're from Australia, but what's really interesting is that these tracks were found at the very, very bottom of the Carboniferous. Okay, so they're from the Snowy Plains Formation. They're way, way down here in what's called the Tornasian. Okay, so that's the very, 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 very bottom of the Carboniferous. You're almost in the Devonian, right? And what's weird about that, like I said, your first actual body fossils of amniotes, right, are up here in the upper part of the Carboniferous.
So that's about 25 million years later or something like that?
Yeah, something like that. So your first footprints are a little bit lower in there. okay? But you've got nothing in between here
Mm-hmm.
until suddenly we've got these footprints down here.
Mm-hmm.
And they're even older than our first temnospondyl fossils, body fossils. So temnospondyls would be the big amphibian group for the Paleozoic. That's what many scientists think that frogs and salamanders evolved out of that group, right? We did a video about Sicilians at one point. That's in that group, okay? So this really, really changes things up, okay? And I want to show kind of how radically this changes. Notice here's the Zechomie tracks right here, right? So they're talking about also the Tiktaalik kind of stuff we talked about before. So what you'd have to have is that you can see here you're pushing everything down is the point. So amniotes were first evolving here. No, actually they're way down here. Well, if amniotes are first evolving there, then you also have to push down the first evolution of the rest of your amphibians, right? And so that's what they're showing here is it goes down, 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 and they're putting it sometime in like the middle Devonian.
Mm-hmm.
Well, that's where we're finding our Zechomie tracks, our first tetrapod tracks, right? So
Right.
they're saying now that the break point, right, where amniotes went one way and amphibians went the other, that that node right there is now almost at the level of like the Zechomie tracks. It's getting near down there. So we had already pushed that down lower, right? So it may even be lower than your first like Ichthyostega fossils. Okay, so everything is getting condensed and squished and shoved down into the Devonian.
Right.
And that's really, really surprising because if you look back over here, this is the classic story, right? This is the breaking point. This is where amniotes go one way, amphibians go the other way, and then up here your amniotes appear. That's the idea is that amniotes are supposed to appear in the Bashkirian up here, whereas the split between amniotes and amphibians is in the Tornasian. Okay, but now we have to move number one here, the amniotes, all the way down to the Tornasian, which means their split has to go down into the Devonian,
And
where we have
that's a
no
big
fossils
gap,
of these.
right? Is that a big gap, like 40 million years or something?
Yeah, I don't remember the actual number, but you could figure out the math here.
Yeah. So it's not just like a few million years or something. But,
No. This is a big change.
right.
And like I said, it's an accordion effect, right? Like you're squishing all of this in a
Everything is
very, very
collapsing.
small amount of time.
Yeah.
Because before we were just collapsing, the evolution of fish into tetrapods, right? That got collapsed. But
Right.
now we're also collapsing on top of it, the amphibian to reptile one.
Right.
And so I remarked to somebody about this paper, it's almost like we're skipping the amphibian step entirely. We're just moving right from fish to like amniotes. I mean, it's getting really, really tight in there.
Right.
So I want to point out some very interesting statements they make in this paper. They say the widely accepted picture of Devonian tetrapods as a low diversity array of primitive fish-like forms must be false. That's what they say. So why do they say that? Okay, we got to go back to our other image here. Okay, so here's our phylogeny from Benton again, right? So amniotes, let's trace that line. Where does it meet up with our amphibian line? It's down here at point F, okay? So it's right there, right? Whereas amniotes he has appearing way up here at Z. Okay?
So the new place is down in point F.
Right. So Z now needs to move down to F stratigraphically, right?
F
Whereas F now has to move deep down into here where it's getting into the A, B kind of range.
Yeah, and
right?
we can see that when it gets into when it's getting down there, now we're getting down into where basically fish supposedly evolved into tetrapods.
Right. And now here's what's really interesting, and this is where that quote I just read comes in. We've only been talking about three groups, right? We've been talking about the tetrapod origins, the amphibians, and the amniotes. We're ignoring all the rest of this diversity here. But here's the thing. If those guys had to be evolving at that time, all of these things had to be evolving, right? So you're not just getting amniotes having to appear right at the Devonian Carboniferous boundary. You'd have to have this other stuff appearing then or a little bit earlier, right? So diadectomorphs and microsaurs and iastopods and ictridians and simoromorphs, all these weird, very disparate groups of amphibian-like creatures, as well as stuff that's supposedly more stemward, so things like colosteids and watcheriids and baphidids. All of these groups must be either in the Devonian or at basically the Devonian Carboniferous transition. And if that's true, we have a massive amount of missing fossils.
Mm.
So this period right at the beginning, we talked about this in an earlier video. It's called Romer's Gap, right? Where you're missing a lot of fossils at this time.
Hmm.
You have very, very few tetrapod fossils. But it's not just there. Now we got to go into the Devonian, where we are getting fossils of tetrapod-like creatures, right? Things like Ichthyostega. Even though we're getting those, we're not getting all these other guys, which
Right.
is really weird, right? And they had this very interesting quote in their paper. They said, um, I'll try and read a little bit back. So they were talking about all these creatures. They say, with the exception of a few in the Devonian, some possible Devonian grade tetrapods in the Tornasian, all known Devonian tetrapods seem to represent a less crownward segment of the tetrapod stem than any post-Devonian forms. Okay, so all the Devonian ones look really primitive, is what they're saying, right? And everything after the Devonian looks more advanced. That's kind of my summary of that.
Hmm.
This suggests a selective extinction with appreciable effects on ecosystem structure. Okay, so they're saying there's a marked difference that's happening in the Devonian of the Carboniferous. We always assumed it was evolution over time, right? But they're saying, well, those guys in the Carboniferous are actually in the Devonian. We just haven't found them. They're somewhere down there. And so why are we only getting fossils of the one versus fossils that are later? Maybe we're seeing like certain ecosystems are getting preserved and destroyed and other ones aren't. Okay, there's like a selectivity going on.
Hmm.
Well, that's starting to sound very, very similar to stuff that creationists have talked about in the past, right? That this is actually representing, for instance, the floating forest environment, where we're seeing distinct kind of ecosystems or sub-ecosystems that are getting preserved selectively, right? Or maybe because they're on the fringes, they're getting buried first by the flood or various pre-flood processes in your model, some kind of catastrophic segment. But the idea is that like you're not, even though all those things lived at the same time, they're not all getting buried at the same time.
That's
And
interesting. Yeah.
that is really, really interesting. And
Mm.
I kind of strains my imagination thinking in the older time scale, thinking about it from an evolutionary perspective. You've got tons of lineages that have to be there, and they're just not getting preserved at all.
Mm.
And that seems really, really, really weird to me,
Mm.
especially if it's tens of millions or millions of
Yeah. So
years
when we're
of
talking
capacity.
about deep time and we're talking about, 100 million years or so, you would expect, this is something that you would expect. You would expect there to be fossils everywhere, right?
Yeah.
That's what you would expect given a deep time perspective.
Yes.
Yeah.
And you're not getting it, right? And what's interesting, they also note this in the paper, and this is something that I've heard Marcus Ross talk about before, other creationists talk about. They say, at present, the oldest record of amphibians, synapsids, sauropsids, and limb stem tetrapods are all ichno records, right? All footprints.
Right.
So all of these groups, the first thing you find in the fossil record is not their skeletons or parts of their skeletons. It's actually their tracks, their footprints. And they say it is well known from later parts of the vertebrate fossil record that trackway assemblages often capture taxa that are not seen in associated body fossil assemblages. So saying this is actually a very common phenomena in the fossil record.
Mm.
And this is something that Marcus Ross has used earlier to argue for this being represented by this being deposited by the global flood, right? With the idea being that basically animals were there, they're getting moved away or they're running away, they're leaving their tracks behind to get buried before the actual bodies of them get buried.
Mm-hmm.
And now there could be other alternatives, right? There could be other hypotheses to explain that. But the point is, once again, this would be a really weird phenomena if this just represents millions to tens of millions years of time of normal evolutionary processes,
Yeah.
right? Like, why would I consistently get this pattern of footprints and then the bodies?
Yeah.
That seems very, very strange if this does represent vast eons of time.
Right. So just three big points here so far, at least I think that I'm getting. Okay. So number one, there are, basically tens of millions of years here where you've got millions and millions of animals giving birth, dying, giving birth, living, dying over these tens of millions of years. So we're talking about a tome of animals. I mean, lots and lots of animals that are just not being fossilized. That's surprising if you believe deep time. Secondly, the body fossils appear later than the ichnofossils, so things like footprints. And not just by, a million years. Sometimes 20 or 30 million years separates the body fossil from this lower footprint. which is
Hmm.
kind of weird again, because if you're thinking in terms of a uniformitarian perspective, yeah, this is just day in, day out living of organisms, crawling around, doing what they do. And you want to think about that in terms of, let's think hundreds of years they're doing this, thousands and hundreds of thousands and millions and 20 million years. But then why does the body fossil not appear with the footprints? If that's
Right.
the case, it's just kind of weird. And then the third thing is that the evolutionists themselves are beginning to say that it has something to do with the environments that these organisms are living in. So there is some organisms have a preference to preservation depending upon the environment, the ecosystem that they're in. And yet creationists have been saying that for a while now, that this is something that is important when we think from a flood perspective or a catastrophic perspective. We're thinking in terms of preservational bias due to those catastrophes. So that's kind of interesting, those
Yeah.
3 points. That's what I've gotten so far. I don't know, does that sound about
No,
right?
absolutely. Yeah, and I mean, I'm gonna add a fourth. This is interesting because you have tons and tons of diversity and disparity that must exist, but we don't have fossils of. So yeah, we've got tracks of an amniote, right? You've got some, but you don't have tracks or bones or anything for tons of these groups, right? And so the traditional story for this was kind of that there's a Devonian extinction. There's like a near end Devonian, late Devonian extinction event. And the thinking was that there are kind of different models of like maybe the explosion of amphibians happened right afterwards, like in the Carboniferous. Some people propose that there was like a huge drop in oxygen levels in the early Carboniferous, and that's why we don't have a lot of tetrapod fossils. There's like all these different ideas out there, but basically none of them are close, right? These things have to start appearing in the Devonian, and that's telling us like, hey, we're missing a ton of data. Like it's not just little bits here and there. It's like huge groups that were just nothing that we're not finding, and that's really interesting because that's putting us in the same boat again. Because as creationists, we argue, yeah, humans were around, right? From the creation of life, and whatever rocks represent the flood or the pre-flood, humans were around, right? And the post-flood too. And yet we don't find their fossils until the very, very top of the Cenozoic. And that's often a criticism. Oh, where are the pre-flood humans? Where are the flood humans and stuff? And it's like, where are the Nectridians? Where are the isopods? There's just tons of groups you can do this with. And so this is the same problem you have with the Cambrian explosion, right? Where you just have all of these groups just popping into existence without having their precursors there. And so I think this is, you brought up uniformitarianism, catastrophism, those kinds of things. This is very much lending itself toward that catastrophic kind of thinking, right? That you're saying the fossil record is not a preservation of just the slow eons of time of things just kind of happening in everyday processes. It's snapshots, right, of catastrophes. But where I would disagree with like a catastrophist, like somebody like Cuvier or someone like that back in the day, they're arguing that there's these gaps of time between these catastrophes, right? And even a modern geologist who would be an actualist, not truly a uniformitarian,
Right.
they would be okay with that, of there being punctuated catastrophes, right?
Yep.
But they're still thinking, well, there's got to be these big gaps of time between these catastrophes.
Right.
And I'm saying, no, it looks like it's pretty rapid. I mean, I'm not seeing these evidences for vast periods of time happening when you look at this fossil record.
Mm-hmm. Cool. Okay, excellent. Now, what about like from a creationist perspective, then how would we interpret this? Is there anything that helps us interpret this from a creationist perspective? How would we understand these fossils?
Yeah, I like what Kurt Wise has been thinking about the floating forest, right? That there's this idea that in the Paleozoic there was a whole, I mean, essentially could be continent scale thing that just doesn't exist anymore. Giant area full of ecosystems that as you move from the outside inward, it's like smaller plants that are more water dependent as you get closer and closer into the center of it. They're bigger tree-like plants that are making up these carboniferous types of deposits, right? And when you look at the Paleozoic as a whole, up until some part of the Permian, basically you're seeing what Kurt would argue is that the plant fossil record matches up really nicely with the disintegration of this floating forest, is his idea. That basically the Silurian and Devonian, you're getting your first fossil plants that are super water dependent. They're on the fringes, right? As you head deeper into the Devonian, or higher in the Devonian, we can say it that way, into the Carboniferous, you're getting these forests, right? And what he said is, I think that animals are going to match that, right? There should be unique kinds of animals where on the fringes, they're going to be more like fish. And the farther you get inward, they're going to be more and more terrestrial, more and more getting closer to like an amphibian to a reptile kind of grade of things. And that's exactly what you see in the Paleozoic. And so, that's a different way of thinking about the order in the fossil record here that doesn't involve the actual evolution of these creatures over time, over geologic time. And in the past, they had in their favor, hey, these things are slowly appearing over tens of millions of years, right? But now it's been condensed. Like now it's like an accordion, right? It's been shrunk down. And so now it's actually, I think, much more in favor with this idea of this kind of deterioration, destruction of this kind of thing. And so you would occasionally get some animals that are, swimming around in the, venturing out other spots, even though they're normally in these particular ecosystem kinds of spots. So, there's a lot more that needs to be investigated there. I don't know of any creationist who regularly works in the Carboniferous. It's just, we don't have a lot of creationists out there, So I think there's some cool ideas. There's some fun things to think about here. And this is a whole area where creationists need to dive in more, and really investigate it. I think there's plenty of evidence for this stuff being catastrophic in deposition in many places. I think before, at some point, we talked about the Joggins locality in Nova Scotia, where you get these upright trees, right, that they claim are a fossil forest where they're growing in place and they're hollow, and you'll find animals sometimes inside them, some of these guys that we're talking about.
Yeah.
And that's in the upper Carboniferous. And it's like, this looks catastrophic. This reminds me of the Mount St. Helens situation, right, where the trees get buried upright. And,
right.
It's not, we don't have to assume this is slow and gradual processes.
Some of those trees are buried upside down. So you have one that's upright, and then you have one, so you have the roots and the tree upright, and then you'll have the roots and the trunk going down.
Oh, that's crazy.
So, I've seen that. So really good evidence that that's some sort of catastrophic deposit, not slow growth of forests over time.
Yeah. And I think there is kind of this theme in geology right now that people are opening up their minds more and more and more to catastrophism. I think we are seeing that as a geological community, which is exciting, I think, for a creationist, and so I think these are things we need to keep looking for. We need to keep looking for evidence of catastrophic burial. We need to stop automatically assuming, these uniformitarian solutions to things.
Cool. All right, look, that's really exciting. I did read that paper and trying to get my head around a lot of that stuff. Obviously, that's your field, your area, but I got the gist of it. And it's like you say, I think it's a bit of a shakeup for the evolutionary community. They're really going to have to rethink a lot of models. And I think it's interesting, that they have this model about how it is that amniotes diversified in the Carboniferous because of an extinction event at the end of the Devonian. And now it's like that whole model, that whole way of thinking has just gone down the sink. Now they've got to come up with a whole new model. And I just think it's interesting how, it doesn't matter whether you're an evolutionist or a creationist. We have these models that we build things on, these structures, we fit our data into these structures. And at any moment, that structure can give way. And so then we have to come up with kind of a new way of understanding things, which just goes to show we've got to be careful how we hold our models. They can collapse at any
and I think that sometimes I've heard creationists kind of harp on that as like, oh, you can't trust anything that the scientists say because they're constantly changing their models, and it's like, no, that's good. Like that's how science should work. We should be changing our models if the data doesn't line up with the model, right? But what it does mean is that we always need to hold these things with an open hand, right? The fossils are real, right? Those footprints are footprints, but how we interpret them in terms of Earth history, that's an open-handed kind of thing.
Yeah.
And so we need to be willing to shift those models, as you're saying, based on the new discoveries that we make.
Cool. Excellent. All right. Well, Dr. McLain, again, just thank you again. This was fantastic. Really enjoyed today's discussion. I hope that you, the viewers out there, would get something from that. I really think this is helpful for us as creationists, as we're trying to think through our own models. Of course, we haven't got it all sorted. We constantly say that over and over again, that there's a lot to do, and we need more creationists out there, and we need a lot more money that's invested into creation research, because we don't get the money from the government like everyone else does. So, hey, you got $1 million? Give me or Dr. McLain an email. Send us an email. That'd be great. Okay, well, Dr. McLain, again, thank you. And I don't know what we'll be talking about next time, but I'm sure it'll be interesting. And for you viewers, that's it. For me, Ken Colson here at Creation Unfolding. Don't forget to share this on your social media platform if you thought it was interesting, because that's really helpful for me. Don't forget to hit the pound button, subscribe, and there's a link in the description if you'd like to give. That's always appreciated. And we'll see you next time. Thank you and goodbye.